The number of bacteria in a certain population increases according to a continuous exponential growth model, with a growth rate parameter of 9.6% per hour. How many hours does it take for the size of the sample to double? Do not round any intermediate computations and round your answer to the nearest hundredth. First of all, we need to make sense of what it is to be a continuous exponential growth model. Let's take those vocabulary words and translate it into mathematical symbols. This is the number of bacteria. So why don't we use capital B of T? So B is the number of bacteria, and T is your independent variable, which is time. We need some kind of initial amount, and we don't know what it is. So why don't we call it B sub 0 or B naught? And it's continuous exponential growth. So this is base E, and then we have a growth rate parameter, and then we also have time in the exponent position as well. We are given R. R is our growth rate parameter. We're going to change this into a decimal 0.096. We do not know what B sub 0 is, or the initial bacteria. It does ask you, however, how many hours does it take for the size of the sample to double? So if we wanted the output to double, we need to translate this part into mathematical symbols. Let's translate that. Size of the sample to double. So if it's to double, and we need 2 times B sub 0. 2 times the initial bacteria amount. We are ready to tackle this problem. We also know that the initial amount is not 0. If there was 0 bacteria to begin with, this problem would not be very interesting. It would always stay at 0 bacteria. So we know that B sub 0 is not 0, and we want to know how long does it take to double this sample. Let's put the 2 B sub 0 over here is now equal to B sub 0 E to the decimal 0.096, and then times it by T. We know that B sub 0 is not 0, so we're going to balance the equation by dividing by B sub 0. This is starting to look nice. This is 2 is equal to E to the decimal 0.096 times T. And now we need the inverse function of the exponential function, and the inverse function is called the natural log function. So we're going to take the natural log of the entire sides, and now we want to write ln of 2 is equal to decimal 0.096 times T times ln of E. But ln of E is just 1. So now we could divide by decimal 0.096, because decimal 0.096 is not 0. Our final equation looks something like this. T is equal to ln of 2 over decimal 0.096. Remember, ln of E is just 1. ln base E of E is equal to 1, right? Let's find T. Use a calculator. Type in ln of 2 divided by decimal 0.96, you should get 7.22022831, and this continues on. We need to round this to the nearest hundred. So you look at the thousands place. The thousands place said it's a 0, so we're going to round down to 7.22. If they give you a question in words, you should answer it back in words. It takes about 7.22 hours for the sample of bacteria to double. And circle it like you mean it.